channel podcast. And here today we are going to discuss about a very interesting topic, which is about additive manufacturing. And we have here with me is a very special guest. All our guests are always special. Dr. Azlan Aripin,
Thank you
on
so
my
much.
right.
Thank you so much. Prof, how are you?
Very well, thank you. So I will probably introduce very briefly who Dr. Azlan is, but it'll be better if he introduces himself. So Dr. Azlan graduated from Mechanical Engineering, UKM, and his specialty is actually, I think, selective laser manufacturing.
Yes,
Selective
laser melting.
manufacturing, yeah. And he is now with City University.
Exactly.
All right. A senior lecturer with City University.
Yes, senior lecturer in City
And
University Malaysia.
very briefly, I think he was the acting dean.
Yes,
All
that's
right. So that's a very important job. And I'm going to invite him to tell us a bit, share with us a little bit about his background, maybe even where you were born, okay, his educational journey, and his research journey, and also his research interests. Okay, please.
All right, thank you so much, Prof. Chiusna. Okay, thank you first for inviting me to this wonderful podcast. I would say this is my first experience. Okay, I try to share a little bit about myself. I was born back then in 1989 in Penang.
Yeah, Penang.
My
Which
father-
part of Penang?
The local will call it as Bagan, but
Bagan.
the people now would know it as Butterworth.
Butterworth.
Yes,
Okay.
exactly.
So that's actually Pulau Pinang, but it's on the mainland. So
Yes,
it's
exactly.
not the pulau proper.
Yes, exactly.
Okay.
So,
And then, okay, to continue on the journey.
yes, exactly. But I was just born there, lived there for a few years before I was, my family settled down in Petaling Jaya. In Petaling Jaya, I was raised there until 17 years old, and then I went to the matriculation, Melaka, and
At
then
17 or a little bit older, I reckon.
yeah, Form 5.
After Form 5.
After Form 5, 17, and then 18 and 19 we were in matriculation. I was in matriculation Melaka, and then directly go into University Kebangsaan Malaysia. So when I was in UKM, I feel my education was sponsored by the Shell company, and then after I finished my study in the National University of Malaysia, went to interview with Shell and also PETRONAS. Decided that I feel closer to PETRONAS, and went to PETRONAS for 2 years.
That was a long time with PETRONAS. Which part of PETRONAS? Which division?
Okay, so PETRONAS, I was with PETRONAS Chemicals.
I see.
They are
Alright.
dealing with the byproduct from the crude oil. So we are making polymer parts.
Okay. All right. So you were in downstream production, actually.
Yes,
not
exactly.
Upstream. What were you involved with? The production of polymers such as?
Okay.
Because you know that is close to my heart as well.
Yes, I believe.
That is something close to my heart.
Yeah, we met in UKM.
Yes,
we met in UKM. I missed that out. I actually met.
You have to
Prof.
say something about that.
Yeah, exactly. It was a very wonderful lecture because in the university, the setting was mostly theory, but not a lot of individuals that are able to make a good storyline out of all these theories. So this, I would say, good storytellers. One of you
One
would
of
be
them was
you.
me, yeah.
A
One
very
of them
good
was me.
storytellers.
Yeah.
It helps me to engage with
Yeah.
the lessons.
Yeah.
And
I think to see the practical implications of the theories in class, because we weren't making so many industrial visits at that time.
Exactly.
When I was younger, I mean, industry was more inviting then, and I used to take, maybe I was stronger then, and I used to take students to places like Johor Bahru, to Sam Sembawang, even to Singapore. So students were able to see right away what you learn in class with what you see in the real world, particularly in oil and gas.
So, yes, exactly. So when I went into the industries, so all the storytelling that I've heard in the university
became a reality.
Yeah, became a reality. I saw the production. Okay, and my responsibility, my roles back then in PETRONAS Chemicals, it was called PETRONAS MTBE. I am the mechanical static executive.
Okay.
When we say the word static, it means that any machines that is not moving.
It's not the engineer not moving.
It's not the engineer not moving.
Not moving.
Okay, so it involves.
So you were actually in charge with making machines work.
We were maintaining. PETRONAS is basically we hate downtime. So we want to reduce the downtime. We have to really take care of all our equipments. So everything from the purchasing until the maintenance, the reliability. So we have to make sure that we have a very less downtime. So our oil production is secured.
Yeah.
Our production is secured.
Okay. You haven't said anything about your PhD.
Yes, exactly.
And how you got your journey from PETRONAS to academia. That should be equally interesting as well, because it's well, I think overseas most people do that. You work in industry first and then you go to academia.
Yes.
In fact, I think I often told you, maybe in class, in between the laughter and all that, my professor was actually a full-time engineer in ICI, very famous British company. And he used to stand in class and used to say, when I was in ICI, I think I believe that as well. So he wasn't referring very much to the textbooks. He was actually intimately engaged with the actual production of petrochemicals. So it was very real and very exciting. And but I'm not supposed to tell my story. So
yes, but even you are not supposed, I'm still engaged with your story. So it's like back 10 years back.
Alright.
So I agree with that point actually. When our lecturers are engaged with the industry, the way they drive, the output of the students will be much different. So when I went into the industries, I went there for 2 years because we know how lucrative the oil and gas industry was, and is still very lucrative. Alright, so it was very attractive for graduates like me to embark on the most lucrative industry. I went there, and then after I experienced my work as the mechanical engineering static, at one point I realized, even though they assigned me in mechanical engineering, but I tend to be very close with this department. It's called inspection department.
I see.
Even though I was designed or I was intended to deliver projects, to keep tab of projects, like how many bolts, how many time required for them to install the pressure vessels or the tank, all the equipments. But I think I always take some time, and more time actually, to study why the failure happens.
I see. Alright.
So it was from there I realized that I tend to have joined this meeting. They will call it as RCPS, root cross problem solving.
I see.
So I spend a lot of time.
It was more challenging.
I think it's more near to my personality.
Yeah.
Really wanted to solve the problem and making sure it doesn't happen. Go deeper.
Why is it happening?
Why is it happening? Somehow inside me, it somehow gave me the message that, oh, you are aligned with research work.
Okay.
Then I tried to rediscover again what my talent is. Yes, I enjoy doing the
You are
engineering.
already talented, but perhaps your passion.
Yeah, maybe the passion.
Yeah.
I enjoy doing the engineer work, but I noticed that I'm living out my dream to discover new things.
You want to follow your dream.
Yes, exactly.
Okay.
So even though there's big bucks coming in, I mean per se Malaysia, per se Malaysia, I don't feel like I'm living my passion, which is to.
You don't feel fulfilled.
Yes, I don't have that feeling.
Your calling is somewhere else.
Exactly.
Okay, then
I tried to discuss the possibilities because even PETRONAS have their own research center, even have their own university.
Yes, that's right. UTP.
Yes, University Technology PETRONAS. So I discussed about the possibilities of going to that kind of area. Before we go to UT as an academician, there's one department we call as capability department. It's a department where we check the progress of the staff technical capabilities.
I see.
So I did not see UTP back then, but I saw this technical capability department. So I tried to find a way, but I think it was not feasible because business directions, they already intended me to be the mechanical engineer. So it's not good for them to suddenly switch my path into research or academic. So when I discovered that, decided that okay, it's quite hard for me to move on from here, I might as well go and pursue my studies.
Okay.
That's what I did.
That's what you did. So you resigned completely from PETRONAS?
Yeah, exactly. I resigned completely from PETRONAS.
They didn't think you would be very, how shall I say, unusual or weird, or they applaud you for that, or they realized that you were very serious about following what your heart is?
Yeah, but I would say that I usually hide my motives. So I mean, my intention, I do not display them. So I did not really declare that I'm going out because I
want to pursue research.
Yes, I want to pursue research. So I just go and do my masters.
Where is that?
In University Kebangsaan Malaysia.
Again,
exactly.
Okay.
I had a very good teacher over there. Even though my I would say him as my mentor. Okay, even though he is one nationality, but I believe his experience have opened my eyes into multi-nationality method of thinking.
And who was that?
Can I say it out?
Yes, of course.
Alright, so I think this calls out for my supervisor or my mentor in University Kebangsaan Malaysia. He would be Professor Zainuddin Sajuri.
Okay. So Professor Zainuddin is no stranger to us.
Yes, exactly.
And then after that, your PhD as well.
Yes, exactly. During my masters, I was exposed with this Ministry of Defense problem. I'm not sure if there's, I cannot remember if there's NDA for it. Okay, so but in short, what I'm supposed to solve the problem was last time we had I tried to keep it very general. We had weight issues with our tank. Okay, so we had to reduce the weight of our tank. Tank meaning our armored vehicle that we bought from one countries in the Europe. So we had to cut out. You had to cut out the parts of the tank, and we have to slice the metal.
Yes. Not find an alternative for the metal.
No, we have to go for a very cheap alternative,
I see.
but maintaining the weight. I mean, maintaining the durability while reducing the weight.
Okay.
I mean, Malaysian way, right?
Yeah, Malaysian way.
So, had to identify what are the properties that are required, what do we have in our market. So, we have basically material engineering comes in very hard in this.
Very deep.
Yes.
Alright.
So, the solution basically we mix two metal plates with a very distinct features, different
dissimilar metal.
Yes, dissimilar metal. It have to be dissimilar metal.
Okay.
But the key of maintaining or compromising the strength at a very low percentage is what do you use to adhere the both metals together. That's where the magic.
So that was the additive technology.
Additive.
All right.
So
a lot of your work, well, it's actually materials engineering, but it's surface engineering.
Yes, I would say it's a surface engineering.
It's a surface engineering proposition, and you probably solved it as well.
Yes, alhamdulillah, we found.
Alhamdulillah, you solved
We
it.
tested. We brought our panel to Batu Arang.
Had it tested.
Yeah, had it tested.
Had it shot.
Had it shot. Okay, so
Okay.
I was quite amazed by the power of research by that time because it was the first time that I see how a systematic way of approaching a problem can actually generate
Solve a quite complicated problem.
yes.
How a structured approach
Exactly.
can solve a complicated problem.
Exactly.
And did you continue with your PhD on the same topic?
Yes, but before the PhD, I would like to add a little bit more.
Okay.
Since I was involved with this ballistic impact,
Okay.
and then I met you. Also, same thing.
Same
I'm
thing.
using the metal panel, so we know that metal is very high hardness and whatnot.
Yes, yes.
And then I saw, oh, Prof. Husna is not even using metal to stop the bullet.
No.
She's using cloth. So
Yeah.
basically, it's oh wow, another
Yes,
interesting research.
It's very interesting
I
research.
remember joining
All our discussions at that time.
Yes, exactly.
Yes.
So after that, I go for my PhD. After that,
Which was supervised by Prof. Zahidi, I think.
yes, it was still Professor Zainuddin surgery.
It was.
Yes, it is.
So, yeah. Okay.
So this time around, it was 2016. No, 2019. Okay, 2019.
Okay. And then,
Some technology just emerged. It was called 3D printing, additive manufacturing.
yes.
Okay, so when I say emerge, it's not like the technology has just been discovered. No, 3D printing
Has
is
been around.
1980s. It's a very long time. Any
Yes.
technology that you found today,
Yes.
I mean, it's become popular today. It was in the
Discovered.
book of the academics like 20
Yes.
years back.
Yes. Yes.
I was
But
surprised.
whether or not it has been made famous is another.
Yes,
matter.
exactly.
It has found great applications, I think. But the technology had been around for some time, as you know.
Exactly, it
Yeah.
was found by a Japanese researcher actually, embraced by the American scientists. So they start with polymers, basically the easiest,
Yes, the easiest material to
to
work with.
manipulate.
Yes. It's
And
always the easiest material to manipulate with. That's why when you have innovations, you better start with that material first.
polymers are like lab rats.
Yeah. Yes. Okay. So then you went into additive manufacturing,
exactly.
all right, for your PhD, and then after that, briefly, because we want to go into additive.
Okay,
manufacturing
sorry.
now. Yeah.
After the additive manufacturing, in fact, when I did my PhD, I was already employed as the lecturer.
At
in-
City University.
Yes, exactly, at City University Malaysia. So, Alhamdulillah, I've been there for 6 years now. I think it's doing a good job. Our students numbers does not just maintain, but it's actually increasing.
Increasing. So maybe a lot of your good work, all right, has been publicized well to people, to students, to potential students.
I would say it's a contribution, but I would say the major contribution would be the areas that we tap. Because a lot of IPT in Malaysia, we are looking into students, local students. But the Malaysian education is actually being praised. I mean, if we say in Southeast Asia,
it's one of the best.
Only Malaysia and Singapore is accredited by the Engineering Council Alliance, Engineering Alliance per se.
Yes, they were
So,
afford.
for countries like Arabs, Africans, even China, going to Singapore and going to Malaysia, we can imagine the price difference.
Yes.
So
it's very competitive.
It's very competitive.
Very competitive.
You can just really see the ROI right away, and that's why Malaysia has a very big potential of becoming educational hub for a lot of. This is what happened in City University Malaysia that I observed. Now 90% of our students are actually international students.
Okay, we can go back again, but now I want to talk a bit about. You will talk a lot about additive manufacturing. I remembered sometime maybe when you were doing your PhD, starting with your doing your PhD, Professor Zainuddin and I went to Iran to present papers, and it was a conference by Amir Kabir University, and the paper he presented was on additive manufacturing. So I thought, well, it's coming back. So, and then additive manufacturing became some sort of the in thing in polymer manufacturing. So, can you share with us the impact of this new technology, so to speak, old but new technology, to polymer processing and polymer manufacturing, but specifically about how prototypes are made.
Okay.
Polymer prototypes are made.
All right.
Even prototypes in general.
I will go a little bit technical on this.
Okay, please go ahead.
Additive manufacturing, if we take the words philosophically, additive means adding.
Yeah.
Okay. I believe the easiest way to find an analogy, they call it analogy. Okay, analogy. We can use our favorite Malaysian dish, which is the cake lapis.
Cake lapis.
Cake lapis. Okay.
I thought you were going to say nasi lemak. Okay, cake lapis.
Nasi lemak is favorite, but cake lapis is also another favorite of Malaysians. So
it's a dessert.
Yes, it's one of the desserts.
Okay, now everybody, we are going to look at kuih lapis as the analogy of additive manufacturing.
Yes.
Okay.
So if you see the
how the cake is made.
How the cake is made. Is it kuih or cake lapis?
Kuih lapis.
Kuih lapis.
It's not cake lapis.
Alright.
It's kuih lapis.
Kuih lapis. Right. So you see that there's like one layer of white color, another layer of red color,
or maybe.
Okay, another white color, and then it's like a layer, and you add it with another layer until you get one solid block of cake lapis. It's exactly the same thing of how additive manufacturing
is done.
Okay,
except that you're maybe you would like to show this to everybody.
Alright, so everyone, this is actually si tanggang, one of our product. Alright, is it okay if I talk about si tanggang? It will be like another 10 minutes.
No, please go ahead, si tanggang.
Alright, so this is actually si tanggang.
I will open, put your hands a little bit. Is it the front part of si tanggang?
Yes, exactly. It's a front part.
He would know.
Because if you see, this is the tanja.
The tanja.
The tanja is a Malay headwear. The tanja is at our front, so this is the front.
Okay.
Basically, all Malaysians should be aware that si tanggang has negative connotations in our society.
Ungrateful son.
Ungrateful son.
That's right.
Okay. So this is basically our project. It was inspired by Dr. Nasrah Hani. Okay. It came from
a colleague
yes.
at UKM.
Yes, it's a colleague in UKM. We were surprised when she came to us and she said, let's do si tanggang. say, why Sitanggang? Isn't Sitanggang have all these bad connotations?
Negative connotations.
Negative connotations.
Yes.
Came back and doesn't recognize.
Hardly a hero.
Hardly
He's
a
an
hero.
anti-hero, you call it.
Yes, exactly.
Not like Hang Tua.
Yes, exactly.
No, why not Hang Tua? It's Sitanggang.
Sitanggang.
It's interesting.
So
Okay.
Sitanggang, why she focused on Sitanggang is like she wanted for us to actually take the positive traits of Tanggang that we have forgotten. Okay.
Like what?
For example, Sitanggang came back as a successful man.
That's right. With a beautiful wife.
With a beautiful wife. Sitanggang started as a village kid. Really don't have any background education, nothing. Alright. And then when
his bare hands.
With his bare hands. Okay, but what Sitanggang had was the courage to try out and
his
to explore.
And explore the world.
Alright. So when he did that, and he did it basically this learning skills, entrepreneurial skills, managing skills, a lot of skills that you need on a ship.
Yeah.
And you're mixing with a lot of another culture. So the spirit of exploring something new made him a successful young man on the ship.
Yeah.
Even become the captain. I mean,
Yes.
how easy it is for the outsiders to even take this local as to give the trust to become the captain. So
of a big ship actually.
yes, it's even a very big ship. So we're not focusing on what happened to Tanggang now. Here's the twist. We are actually making a story of Tanggang multiverse. What if Tanggang is given a second choice?
I see. A second chance.
A second chance. Yes, a second chance. Alright, to
redeem himself.
To redeem himself.
Redeem himself.
Exactly.
Right.
So when you want to embark,
both you and Nash are very kind. This is very good.
So basically, we want to instill to the new generations the spirit of trying something new, exploring something new. If you talk about additive manufacturing or 3D printing, it's a very interesting technology, but if you want to embed it in the industry now, you will receive almost a lot of very challenging questions on implementing it. Because you see, the mind of accepting a new technology, you have to prepare with a lot of challenges.
That's right.
So this kind of we want to educate the new generation to actually know the designing part is no longer up to the third party. Nowadays, children, you should need to know this very well. The designing part depends on you. You can design and you can manufacture anything, even in your own house.
Yes. Okay, can you say, for example, can somebody, let us say, school children, a group of school children in Sekolah Menengah Jalan 3, let us say, in Pangi, can they make Sitanggang? If there is, can they make Sitanggang in, if there's, I don't know, school were to buy a tabletop fabricator, for example, can they make Sitanggang?
Yes,
and what should they have? What kind of skills should they have?
Alright. So to answer your question, I would say absolutely.
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 Okay, absolutely.
And I can only come out with absolutely after visiting not less than 10 schools.
So all the schools are at it.
When we went to the schools, you know, schools, they have this science week. Minggu menghayati science, minggu aplikasi. Even though we don't go for science week, we go for our education fair per se. Where do you want to continue your studies or whatnot? They will invite a lot of booth, you know, booth for this, booth for that. So at first it was surprising that, you know, we are bringing 3D printers, you know, on the table. When one or two of the school children came and see our 3D printers, we always give them a 3D printer to see and also a 3D pen for them to experience, because we believe in the Bloom taxonomy, you know, C, P, A. So you have to practice it to feel it. So when they practice it, they felt it, give us around 1 hour at most. Our booth will be lined up from our booth until the door of the classroom, even outside of the door of the classroom.
They're all waiting to
embark on
this journey. So I would say, and I'm sure you will be the first to agree with me, that this technology is very democratic. In a sense, it's very when I say democratic, it's because the technology is not something that you have to go very far. You have to spend a lot of money. You don't have to invest in something. And I know as an engineer, the first thing you learn is how to, count your finances when you have to set up a company, a manufacturing concern. But how much different is that? I think there is something that is profoundly different if you want to set up a manufacturing concern, so it is so accessible, producing sitanggang here, and producing something, a component, then the opposite of additive manufacturing is
subtractive manufacturing.
Making something using injection molding, let us say, is a conventional method of processing. So how different, what are the differences and similarities you would talk about manufacturing something using additive manufacturing for, let us say we talk about sitanggang, all right, using your additive manufacturing and injection molding.
I like this question.
You like this question?
I like this question. It's basically the
You're
opening.
hoping someone, I would ask this question.
Exactly.
Yeah. Yes.
Alright, because
we spoke a lot about injection molding, remember?
Exactly.
Yeah. Okay.
Alright. So, in the manufacturing world, okay, so we are used to 3 methods of manufacturing. Okay, in our classical times, we would have like a block of a polymer, of a block of a stone, and then we carve out the stone to make our final shape.
Okay.
Okay, so this is the earliest method of manufacturing that we have recorded, and it is basically subtractive manufacturing.
Chip it away.
Yes, exactly.
To make your whatever shape that you want.
Exactly.
Okay.
So after that, we went into this manufacturing we call as formative manufacturing. Formative is basically you have a die of whatever final shape that you require. Alright, and then you put the liquids, okay, of your final material, let it solidify, and you open back your die, and then you get whatever shape that you want. Alright, so this is what you call as formative, and it's the current use, the most
prevalent.
Yes, most prevalent, the most popular right now.
Yes.
Alright, so everyone is using formative manufacturing because it's very fast. They can produce a lot of items.
And I always remember in the classes near net shape.
Yes, exactly.
Near net shape. Right.
Near net shape.
As near to the final shape as possible. Yes.
Exactly. Okay, so before I go to additive manufacturing, I would like to share a little bit what was the setback that we have in the first 2 manufacturing methods. So firstly, now on the subtractive manufacturing, as we were talking about chipping out the material, so the chipping out of the material would be your waste material. Alright, so this subtractive manufacturing will introduce, now that we have the sustainable development goals, and our material input is one of our biggest asset. We are not that easy to simply waste our material, so which is why most companies, we have stopped subtractive manufacturing unless it's really not possible. They have no choice. Okay, next, moving on to formative.
I see.
Alright, so this formative, you get a near net shape, like you say. Okay, we solved this problem.
We solved this problem of chipping away.
Chipping it away. Alright,
but
there's a but to it.
That's a but.
Okay, so as long as we don't, the industry will always keep on having upgrades. Okay, they cannot make like a porosity inside of the shape. Means you cannot make a solid ball with a hole inside the ball. Alright? So you cannot make a ball with a cavity. That's a problem with formative. Because you need a dye, and the liquid will fill in all the space. There's no such thing as you want to. Let's take a beehive. The beehive. You see, a beehive is like a solid ball from outside. But when you go inside, you cut the beehive into half. You will see it's actually full of porosity, and it's full of complex. It's a very complex shape.
Yes.
Okay.
Full of empty space.
Full of empty space.
But it is integral.
Yes, but it's integral.
Yeah.
A committee is living inside it. So, challenge you, if you just cut off the beehive and give it to a formative manufacturing industry, it won't be possible to recreate the same thing unless they have to assemble. But to create it in one piece would take, just one die to.
I think you call it a honeycomb structure.
Yeah, honeycomb structure.
Okay.
Alright? So, there must be a way to produce item that is, you can even make it a complex shape. You can introduce porosity inside it. Alright? So that's where additive manufacturing comes. Alright? Because you want to make it one layer and another layer you can skip a few parts, and then at the third layer you do back that part, so you can introduce all these small holes. Alright? So in a way, if you take back whatever that we see in the nature, the mother nature, alright, you don't see that all these items, all this living nature is actually a solid, like a solid skeleton. Okay, they have a very small porosity, but repeat, we call it a cellular structure.
Yes, yes. Okay.
Okay, so in a way, this cellular structure is only now in this age that we are able to observe and form it, manufacture it, thanks to 3D printing. So in a way, we are getting closer to how
natural materials are fabricated. Okay, so
exactly.
It's some sort of how do you say it? Biomimicry of fabrication.
Yes, exactly.
How can you call it? Biomimic fabrication. I don't know. We have to think of the word.
Think of the word.
Okay, now I have to ask you, I don't know whether it's considered a technical question or not, but even I want to find out, is that how do you, so to speak, give instructions to the machine? How are you going to give instructions to the machine to make them fabricate a whole complicated structure? What do you actually do?
Okay. Without the real machine here.
Yeah.
Without the real machine.
It's not very big.
Yeah. Actually, you can get it it's a very small machine. The machine, it will deposit layer by layer through a nozzle.
Yes.
Alright. It has a nozzle and it will deposit one layer, layer number 2, layer number 3, but it happens very fast. Alright. So
but
how did
you do it? How did you tell the machine to do that in the
Yes.
first place?
So how do we instruct this nozzle to go which part? Okay.
Yes.
So the nozzle will read our drawing. Our drawing means our modeling.
I see.
So we have to come up with the 3D model through any now you can get it very easy, even through online Tinkercad. Okay, if I can say it. Okay, you can even draw, you can even take, alright, any shape that you want. This shape, you will just send it to the machine. The machine will read the shape, and the machine will print it exactly how our model looks like.
Yes.
That would be it.
Would you consider Sitanggang a complicated design?
Sitanggang is intermediate, it's not so complicated. How do we measure complicated? We had this we had this argument.
Yes.
Some says that if we have a lot of porosity
don't ask
inside.
me the old definition because I'm used to this formative manufacturing. All right. So how do you define complicated design?
If I put
I know because there must be something about the ability to fabricate cellular structures.
Yes, exactly.
Yeah, so, okay.
Alright, so I would
This
say...
is an intermediate design.
This is intermediate
Okay.
design. It's not so complicated.
Okay, your definition, and then give a simple design and give an intermediate design. We've got Sitengkam, and a complicated design.
Okay.
Okay.
Basically, the final product that we fabricate tells us how complicated it is. Okay, let's say we take a 1D, not 1D shape, a basic 3D shape, like an egg or a circle. Alright, so this is one basic shape. So this is a very easy, simple design.
Is a donut complicated?
No, it's a basic shape. It's a basic shape.
A donut with a hole.
A donut with a hole, but the hole is not inside, no problem. For 3D printing, it's still easy.
It's easy.
It's easy.
But if the hole, the spaces are integrated in
Yes,
the design, then it's a complication.
Yes,
Okay.
when you start to introduce porosity, specific porosity, it's not accidental
Does
porosity.
that mean that the degree of complicatedness, so to speak, corresponds to the number of holes in it?
That would be one factor.
That would be one factor.
Because I would say one factor is you want to create a porosity. Specifically, I want to create the porosity. For example, in the Sitanggang, the porosity have to be at the mouth area. So I want specifically inside the mouth area. So that's one factor of complication that I have increased. That's number one. Okay, but Sitanggang, if you see, is a mix of many triangles and
squares and rectangles.
Rectangles and pyramid that you have. So that is another factor of complexity. Okay, so complexity, if I print it in a single color, like for example everything is white color,
that's not so
that will be simple.
Yeah.
But if I put it into multiple colors, then I introduce another factor of complexity. So I already talk about
shape?
4. Okay?
Shape?
4. Yes, exactly. The colors, for example,
Colors,
now it's a
shape.
mix of brown, blue, yellow and red. So in a way, you have shape, the colors, the porosity, the addition of
Colors?
yes, exactly. I think it's 3. Color, shape, and the porosity. Okay, so these are the example of 3 factors. So there is more factors that contributing to how complicated the design can be. But with 3D printing, you can just produce it in your own house.
Okay, in Malaysia, you said that industry has not been very forthcoming in producing components from using additive manufacturing, 3D printing.
Yes.
Why is that? What are the constraints? Why are they not accepting it? So they should be rushing, shouldn't they?
Yeah, they
should
should.
be doing, because it's cheap, it's accessible, it doesn't need much training. You just have to have design engineers, that's all. And then apart from paying these people, you just have maybe semi-skilled workers.
Okay.
Yeah?
So when we talk about industries, they are dealing with machines and reliability of the machines, and sometimes even the safety of the operators. This is speaking from industry. I'm changing my head into industry. Anything that we produce, it has to have some sort of like a certification.
Okay.
That the industry must be able to predict how this material will react as a performance, will it sustain? Okay, so using our conventional methods, it is already established. Alright, because you get from a full liquid form and change into solid form. There's not much of unpredictable aspects, behavior that you are looking at. So in order for them to run their industry, they need something that is predictable. I would say it's predictable. When 3D printing comes in, I won't say that it is not predictable. I would say that it's not predictable yet. Okay.
So that is
in the early stage,
it's not so repeatable.
Because
the quality is not that repeatable.
if you change the printers, you will yield out a different set of mechanical properties. Okay, so this kind of unpredictable performance is the gap that we are studying, and basically my PhD also is based on this kind of problem.
Okay, that is very interesting. Okay, you have accessibility, alright. You don't need very much capital intensive, but the design is very malleable because you can then it's very near to, like we said, biomimicry of natural, how natural materials are not natural materials, natural things, natural components are made. So the constraints of, we talk about the constraints of repeatability, right? The constraints of repeatability is what you said is the biggest constraint. But if you change the strategy, for example, don't go for mass manufacturing. Maybe it's the philosophy of adapting something that is so successful in formative manufacturing, which is make as many components as possible, make it repeatable. So change the philosophy, make it something that is more akin to IR5, which is make bespoke materials, smaller quantities. Exactly. So what do you think to my suggestion?
Okay, very good thought and perspective, which brings back to the advantage of additive manufacturing compared to formative manufacturing. Okay, so when we talk about additive manufacturing, okay, previously we are using formative manufacturing. I mean, right now we are using formative manufacturing. So if we want, for example, a phone casing, let's take a consumer-based perspective. You can only get the shape of the casing that is available in the shop. You see this? Okay, so we are used to that. If what we intend or what we, what are we interested in? Like for example, I would like to have like a little bit of Doraemon, but like for example, if you want to create AI image, right? Now you can prompt AI image. Okay, please create a photo of myself. Let's say if not married, with a wife or something like that. You can create that photo and you can enjoy that thing. So you cannot do it with formative manufacturing because everything that you want is limited to what the supplier is making. And if the supplier wants to attend to you, it wouldn't be the price of the things that you can get now at a cheaper rate, cheaper price. It will be very big price because they have to make a new mold, a different design. Okay, it will be tenfold of the actual price. With 3D printing, you think of any single, I want to make a 3D model, my door handle is broken, alright? So I just had the idea of how it looks like, alright? And then just find anything that, a model that I can find in the 3D, is, the library is large, you can basically find anything and you can just print it right away. Okay, you can even put your name on the door handle.
So precisely this is what I'm arguing. Before, when we were talking about manufacturing, we were always talking about mass manufacturing, because the more you manufacture, the more you produce. It's volume, right? It's dependent upon volume, and 3D manufacturing is more or less custom made. This is how, like we make our cottage industry. You know, you make one songket, and in order to make 10 more songkets, it takes about a month. So the cost is very high. Is that going to be the same situation, say, with 3D manufacturing? This is what I'm saying. You have to change the customer perspective.
Yes, exactly. It aligns with the IR 5.0. That is why, if we want to bring this 3D printing to the generation that is already familiar or require some design changing method of thinking, it's very hard because their mind is like, we have to source out. If there's we try to source out this kind of part, if we cannot find it, then we cannot do it. You have to buy a new one. With 3D printing, you don't have to source out this product. you can just design yourself and print it out.
Okay.
So that's have to shift, and we are trying to implement this or open the eyes of the new and younger generations.
Alright. It seems that your target is always on the younger generation.
Exactly, the younger generations.
You're giving up on the old generation.
We're not giving up, but I think it takes more effort. So
yes. I think it's the industry.
Yes.
It's the industry rather than it's the age. It's the age of the industry.
Yes, it's the age of the industry.
think-
So I want to add a little bit more.
Yeah.
With the younger generations, I had the point just now. It went off the point. Okay,
Then
continue.
we get back to that. We want to come back to before we the last thing we want to talk about, because we have covered quite a lot of things, is your training module.
Okay.
Okay, your training module, maybe a little bit about it. Not well, some that could interest our viewers. All right, why they should attend it, and how it's going to, especially I think professionals, engineers, and designers. What impact will that make on them? All right, and even I don't know, lay people, children, young people. So
Okay.
please talk about your training module now.
Alright, so I have this training module. Thanks to EVSB as well. Okay, for identifying this the appreciating this module. Okay, so when you want to know if one technology is, I would say, have a good return for investment, you have to see who's using it right now. Okay, so I would say number one, 3D printing, you might not see a lot of our industry, but do you know that the rockets in NASA, okay, even the military copters in the armies of the US, they are
using this
3D
technology.
printing all their
All the
parts.
components.
Yes, all the components, because it requires a very unique shape, very complex shape, lots of porosity, and at a very fraction of the weight. Only can achieve. Alright? So my training module is basically I want to tap this magical discovery and bring it back to our communities, societies, and industries.
And really, the best place to try innovative industry is aerospace. Because aerospace, I understand from reading about manufacturers like Boeing and Airbus, they send their components to be made in CTRM, for example. I used to imagine, why is that possible? Because for them, they make the standards. So as long as they accept it, then it's their standard.
Yes.
So it's in a way it's a very democratic process.
Yes.
You are embarking on something that is not governed by rigid international standards and so on and so forth. So there is a lot of room for experimentation and, most important, acceptance, I think, by the industry.
Even if you're talking about that, the ASTM, American Society of Testing Machine, actually came to Malaysia and Singapore. This year I attended the ASTM, but they are focusing on additive manufacturing. They want to be the first that come out with the standard. So basically can monetize from it or whatnot. Okay.
Okay, as an academic, last question. Do we have time? Do we still have time? So, do we have a lot of time, or it's okay? We can go on.
Yes.
Okay. So, as an academic, all right, as an academic, and as a, how would I say it, as a proponent, all right, of additive manufacturing, how do you see additive manufacturing as a subject? As a subject in mechanical engineering or manufacturing engineering, where does it sit as a subject? I think it might not be too relevant to make, say, additive manufacturing like a degree, but perhaps as a subject, as a core subject, or maybe at the postgraduate level. What do you think?
I'm just going to talk about a context setting that we have right now. Okay. I would say that a lot of people would agree on this statement. Our engineers are being paid less. I mean, it's the wage is maintained from 10 years back. Okay. It's a known fact. It's a known fact.
It says, but you said you were paid well in PETRONAS.
Only some industries are enjoying, but the wage are still the same. The wage are still the same. So, as a lecturer myself, we are responsible to look into this problem. Okay, why our engineers are not being paid higher wages? So, it drives down back to the ability of our graduates to design and solve real problem. So, to design and solve, usually they have in their final year project, they have something that they want to solve. To solve for the water pollution, they want to solve for the lightweight of the vehicle, everything. But their project will end up using acrylic board. They will use some plywood. Okay, they will weld a few metal plates around. So this exposure of actually all this way of doing the prototype is 40 years, 50 years back. It's a long time.
It's not keeping current.
No, it's not keeping current.
And what is really happening?
What is really happening? So, I went to a lot of schools competition, becoming the jury. Okay, alhamdulillah, I see some changes in the students. Some of it are start doing using their prototyping using 3D printing. With the 3D printing, their minds to think of the solution instead of very narrow to what only we have acrylic, some few screws. Their mind really go diverge. They are not constrained of their solution based on the manufacturing methods. They can put the manufacturing constraint aside, just focus on what you want to solve. Later, a 3D printing can print anything you want. So, it really, untie some part of.
It's a lot of freedom, isn't it?
A lot of freedom in designing. If you want to put technical, yes, additive manufacturing can be put inside the manufacturing process. Every engineering, pure mechanical will have that subject, yes.
Second here.
But with that, the designing part of our students will be unlocked.
You said something very interesting. Our engineers are perhaps limited in their capacity to design and solve problems. So, okay, you can tell the technical part about 3D manufacturing perhaps in 2 or 3 classes, right? It's not that much different. Okay, second here. But how do you incorporate this more inherent ability that you need, the ability to design and solve problems? How would that come in with the introduction of 3D, say, manufacturing and something higher in the Bloom's taxonomy?
All right.
What do you suggest?
What I done, okay, I have to divide my answer into the new generations and also the
old generation.
The golden generation.
Old generation is what, like me?
I don't want to say that. Okay, the new generation, usually I would just bring one 3D printer, okay, and I will ask, okay, I have like 40 kids in front of me, okay. They are very curious. What's this thing that is? They will call me as sir because they are not. They go, what item is
sir,
this?
What is it?
What is
what
this?
Have you got?
I will just ask them. Okay, I want you to think of an item. Okay, we're going to make a keychain. Okay, I want you to think of an item that everyone in this room will be interested to buy in. Okay, I want you to write your answer down and give it to me. So I will get a lot of answer based on different generations. Okay, for the young generations, you will see Roblox, Marvel characters, anime, whatever. I will read out and I will ask all of them to vote. Okay, whoever get the most vote, I would take them as the winner for the designing stage. Because you are very customer, you are customer eccentric.
Yes.
You have high empathy. You know what all your friends want.
Yeah.
Okay, and you manage to come up with a good design, something that people want to buy. And then I will just take their answer, search for that model, and I will print it on the spot.
On the spot.
Because on the spot is only 30 to 40 minutes at most.
Okay. And can you give an example of the winner?
Yes, exactly. The latest that I did is actually with the older generations. And the characters that won the heart of the old generations is the Stormtrooper from the Star Wars show. But it's not, it's like 40s to 50s, the Stormtrooper. So everyone voted for that Stormtrooper. I printed it. It was 40 minutes. They saw everything from the customer studies, design. It's not prototyping. You're printing the product itself.
It's not
The
even
whole
prototype.
supply chain is right there on the table, and print it out and give it to him, and he can just sell it because you already know. And it's just a polymer. It's a very fraction cost, and you can.
For a polymer processing engineer like me, this is a revolution that I have to face. Because even when I give kuliah before, and then even when I am addressing, for example, I give a training also, prototyping is a very important aspect. Producing prototypes is a very important aspect of the processing value chain. So now you are telling me that this step is becoming nearly obsolete in the additive manufacturing. Yes, it's almost. And people then, academicians, trainers, academicians will have to think, revolutionize the way they think about the curriculum as well. So what do you say about that?
Exactly, that's what I try to implement in the mindset of the new generations. They saw it, they experienced it. I just think of what people like. I just find the design, and I just print it.
And you cut out all these steps.
Within the half-day session, I can make money from what I produce. Basically, it's the same thing. Industry, you just have to study about your customers, solve the problem. It's the same thing, but with 3D printing, you can just fit it into one module. Okay, there you go.
You have to. You are able to cut out all these expensive. I would say expensive and time-consuming steps. So that is actually the revolution. I would call it the revolution in additive manufacturing. So I think we have come to nearly the end of our podcast. I enjoyed it tremendously.
Yes, I enjoyed it too.
And I hope you do have. I think I learned a lot. I when I first started out, the time when I went with Professor Zainuddin, when he presented the first paper on additive manufacturing with our colleague, I was fighting against, when you're old, you say, no, I don't want to learn anything new. But you have to learn when this is something that is going to revolutionize the way that affects the fundamentals of your discipline. And it has, and I found it to be very exciting, and I thank you very much.
Thank you so
for
much
introducing it to us. And I would advise everybody to follow our course, and please come on board and join Dr. Azlan's course with EVSB. So with that, say goodbye, and thank you very much. So don't forget to join us. So here's me, Professor Emeritus Dr. Husna Azhari, and Dr. Azlan. Goodbye. See you again, inshallah. Assalamualaikum.
Waalaikumsalam.